Okay, now I'm going to be doing the homework for 10-7. There's 4 problems here, but we're actually getting in some business problems, so let's take a look here. Number 33, give me a second here, let me see what this was. Okay, number 33, I have, it's a cost analysis problem. So you're given C of x is equal to 2,000 plus 50x minus 0.5x squared. So this is your cost function. And it's the cost in dollars of producing X food processors. So X is the number of food processors. And C of X is the cost in dollars. So for example, if we make 0 food processors, that'll be 0, it'll cost us $2,000 just to run the business, okay, if we don't make any food processors at all. So as we increase the number of food processors, our cost is going to change. The first question here is find the exact cost of producing the 21st food processor. Find exact cost of producing the 21st unit, I'll just say unit, food processor, okay? So the way we look at this, this is a parabola. It opens down, it goes something like that, okay? So what we're trying to figure out is if we make 20 food processors, we're going to have a certain cost, right? That's the cost of making 20 of them. Then if we make 21 of them, we're going to have another cost. That's the cost of making 21. They want to know the exact cost of producing that 21st unit. So it's going to be the difference of those two. So this should be the cost of producing 21 minus the cost of producing 20. Which means I need to plug 21 into this, everywhere I see an X. So I'm doing this on my calculator. I'm doing 2,000 plus 50 times 21, so I'm plugging in 21, and then minus 0.5 times 21 squared. And I should get $2,829.50 minus, now I need to plug 20 into this. So 2,000 plus 50 times 20 minus 0.5 times 20 squared. This is $2,800. So if we take the difference between those two, we get exactly $29.50. So I'll put my dollar sign out there. That's how much it cost me to make that 21st food processor. Now what we're going to do is we're going to use some of the calculus to have us approximate that answer. So what we do is we imagine that if we go back to 20, all right, actually let me write down what part B is asking. Part B says use marginal cost to approximate the cost of making the 21st food processor. So use marginal. When you see the word marginal, you need to be thinking derivative. Use marginal cost to approximate cost of making the 21st unit. So we know exactly how much it costs us to make the 21st unit. All this problem is doing is showing us how we can use the marginal cost to approximate this answer, that we're going to get a pretty close answer. So back in the picture, what we're doing is we're saying, look, if we want to know what's happening at the 21st unit, we go back to the one right before it, the 20th unit, and we get the slope of the tangent line right there. And the slope of the tangent line should tell us our rise over run. It should tell us how much we go up by if we go over 1. Okay, so let's figure out what this up here is asking us to find the derivative of the cost function at 20, not at 21, but at 20. It's always 1 unit behind where we're looking. So I need to take the derivative of this function first. So let me take the derivative of this. I'll do it right here, c prime of x. So the derivative of 2,000 is 0. The derivative of 50x, the 50 comes for the ride. The derivative of x is 1, so that should just give us 50. And then here, the negative 0.5 comes for the ride, and then the 2 comes down. 2 times 0.5 is 1, so this should just be minus 1. And then when we took derivative of x squared, the 2 came down, we just have x to the first power, so just 1x. In other words, 50 minus x. That's c prime of x. We want c prime of 20, so all we do is we plug in 20 here, so we get 50 minus 20, which is 30. And so that should be our approximated marginal cost of producing 21 units. So it should be about $30 to produce that 21st unit. And you can see it was $29.50. We approximated it to be 30. We're pretty close. All right, let's look at number 37. So for number 37, we have, this time instead of a cost function, we have a profit function. So we have P of x equals 30x minus 0.3x squared minus 250. And here they even give us a domain that our x has to be between 0 and 100. So this is the total profit in dollars from the sale of X skateboards. So X is skateboards, number of skateboards. And P of X is profit in dollars. And for some reason, we can only sell between 0 and 100 skateboards, all right? So for part A, find the exact profit of sale of the 26th skateboard. So what we want to do is find the profit at 26 minus the profit at 25. So if we want to know the cost or the profit of that 26th skateboard, we have to take the profit at 26 and subtract the profit at 25. So we're going to plug in to this 26 and then we're going to plug in 25. So I'm going to go 30 times 26 minus 0.3 times 26 squared minus 250. And when I do that, I get $327.20. Then I'm going to plug in 25 here. So 30 times 25 minus 0.3 times 25 squared, and then minus 250. So I get 312.50. And now I subtract these, and I get $14.70. So that's the exact cost or profit of selling that 26th skateboard. Now for part B, we're going to use the marginal cost to approximate. So we want to approximate the profit of the 26th skateboard. So what we want to do is we want to find the derivative at 25, at the 25th skateboard. Okay, we're approximating the profit at 26th skateboard. So to do that, we take the derivative at the 25th skateboard. And again, it's because we're looking back and looking at the slope of that line and seeing where we would be. So I need the derivative. Let me get the derivative. I haven't done that yet. The derivative of the profit is, derivative of this is 30. I'm going to start showing less work here. This 2 comes out, that becomes minus 0.6 x, and then derivative constant is 0. So now I take that, come up here, 30 minus 0.6 times, I'm plugging in 25. Let's see, we should get something pretty close to 1470 here. 30 minus 0.6 times 25, I get exactly $15. So pretty close, $15. All right, let's go to 39. So for 39, we're going to start changing gears here a little bit, I think. 39, they give us another profit function. So the profit function they give us is P of x equals 5x minus 0.005x squared minus 450. And then again, I've got x between 0 and 100. Give me just a quick second here. I've got to take care of something. Let me mute this. Okay, sorry about that. I had to take care of that. All right, so for this problem, this is profit from sales of DVDs. It's profit in dollars. X is the number of DVDs we have. It says evaluate the marginal profit at the given values of X and interpret the results. So for part A, it gives you X is 450. And for part B, it gives you X is what, 750? 750. And it says to analyze and interpret marginal profit. So when they start talking about marginal profit, I need to take a derivative. So let me go ahead and take the derivative here. This is going to be 5, and then minus, and then we bring the 2 down here and multiply, we should get 0.01x, and then derivative of constant is 0. So this is my marginal profit function. And what I want to do is I want to evaluate the profit at 400, or the marginal profit at 450. So what's P prime of 450? Well, we just plug 450 in there. So 5 minus 0.01 times 450. So we should get 0.5 here. So what does this mean? It means that if we were to graph this profit function right here, again, it would be some sort of parabola, okay? It would be some sort of parabola, and it says if we sell 450 DVDs, the slope of the tangent line is 0.5. What that means is that our profit is increasing, right? Because it's a positive number. This would mean profit, I should say, at sale of 450 DVDs, profit is increasing because it's a positive number by, and remember this is in dollars, so that's 50 cents. So that's 50 cents per DVD. Okay, so as we're selling right now, our profit is going up by 50 cents per DVD. Now it's not always going to be like that. It's going to change as time goes on, and it depends on how many we sell. As you can see, now we're going to go and see what happens when we plug in 750. So if we do our marginal profit at 750, and we compute that, so we're plugging 750 in right there. 5 minus 0.01 times 750, that's going to be negative 2.5. So what this means is at the sale of 750 DVDs, profit is decreasing. Now it's decreasing because it's a negative slope, so it's coming down. Decreasing by $2.50, because 2.5 means $2.50 per DVD. So it's kind of like our profit was going up, but then once we get to a certain point, too many DVDs, our profit actually starts to drop, which is weird, but sometimes that's the way these profit models work. There is a kind of a point at which you get the most profit. All right, that's number 39. Let's look at number 43. This is the last one here. All right, so they give you a problem for revenue analysis. The price in dollars and the demand for a certain brand of running shoes are given by this equation. X equals 4,000 minus 40p. All right, so P is the price in dollars. And X is the demand for running shoes. Okay, there we go. All right. First thing it says, part A, is to express the price P in terms of demand, and then define the domain. So right now, our demand is expressed in terms of price. So you give me price, I'm going to be able to come up with demand. Part A says express the price in terms of demand. So we want to solve this for P. So let's do this. Let's subtract 4,000 from both sides. And then let's divide both sides by negative 40. So I'm dividing everything by negative 40, and I'll get P over here, then each of those divided by negative 40. And I'm going to rewrite this as negative 1 over 40x. And then the negative over negative is going to become plus, and then this should just become 100. 4,000 divided by 40 is 100. So if I want, I can write it this way. Price is equal to negative 1 over 40x plus 100. All right? So part A, express the price in terms of demand and find the domain of this function. So when we talk about domain here, think about it this way. Let me check something real quick. Something seems off here. What am I doing? Yeah, that's right. Okay. Okay, so what is our domain, sorry, is what we are looking for. And to get the domain, we actually can come back to this right here. Our demand for running shoes, what's the highest the demand could be? Well, what's the biggest this could ever be is the question. So the biggest this could ever be would be if we had 4,000, because if not, it would be 4,000, we're taking away something. So it's got to be the biggest this quantity could ever get would be 4,000, right? If I do price of 0, 4,000 is the demand. If I do price any other positive number, then it's going to start taking away from that. So I know that the highest value of X here is 4,000. And then the lowest demand I could have, well, that would just be 0, right? Nobody wants my shoes. Okay, so this is our domain, and it's based upon this information right here. So that's part A. Part B, what are they asking for in part B here? Find the revenue from the sale of X pairs of shoes. So, revenue, okay, is how much you're going to bring in. Revenue, by definition, is the price you're going to sell your units for, which is P, times how many units you sell. So if I have these shoes, if I'm selling them for $10 a piece, and I sell 20 of them, it's going to be 10 times 20, that's how much my revenue is going to be. So this is the generic formula for revenue. If we know the price, X is the number of units we sell, this is what we use. So now what I'll do is I'll plug in for P, -1 over 40X plus 100, and then I'll multiply that times X. This gives me -1 over 40X squared plus 100X. This is my revenue function. Okay, that is part B. And the domain, as far as the domain, we should have the same domain that we had for our P function. So our domain should not change. Okay, so everything here, domain of this is going to be the same thing. And then for part C, find the marginal revenue at the production level of 1,600 pairs of shoes. And then find part D is find the marginal revenue at 2,500 pairs. So for parts C and D, for part C, they want the marginal revenue, so the derivative of the revenue at 1,600 pairs. And then for part D, they want the marginal revenue at 2,500 pairs of shoes. All right, so in order to answer part C and D, I have to get the marginal revenue function, so I need to take the derivative here. So here I've got a constant attached to this. The 2 comes out. 2 divided by 40, I can reduce that to be 1 over 20 x. So the power went down here, the 2 had popped out, reduced the fraction. The derivative of 100x is just 100, because 100 comes for the ride, derivative of x is 1. So this is our marginal revenue function. So this is what I'm going to be using to plug in up there. So I'm going to be doing on my calculator -1 over 20 times 1,600, and then plus 100. And then for this one, I'm going to be doing -1 over 20, and then 2,500, and then plus 100. And when I do that, I should get $20 for this one. And then on the other one, part D, I should get negative 25. Okay, so let's interpret these results. If I sell 1,600 pairs of shoes, then my revenue is increasing. So at 1,600 pairs, revenue is increasing, because it's a positive answer, at $20 per pair. So at that level or at that quantity of shoe sales, 1,600, my revenue is going up, okay, at $20 per pair. Now, if I get to 2,500 pairs sold, my revenue is actually going to be going down. And so I can say at 2,500 pairs, the revenue is decreasing at negative 25, or we can say decreasing, let's say decreasing by $25 per pair of shoes. So the key is that it's decreasing. That's why I didn't use negative. It's decreasing, going down by $25 per pair. All right, that's it. Covers that 4 problems out of that section.